Yes, thank you, and good morning, and welcome to the third day. It looks like most of us survived and are back in the room this morning, which is good. Just to recap, it's David Bosschaert over there, still working for Adobe, and my name is Carsten Ziegeler, working for Adobe as well. So let's get started with the presentation about Dockerizing applications with OSGi. And if you want to do that, or containerizing applications actually, if you want to do that, the first step is you have to create your application, obviously, and you want to run it in some kind of container. And it's quite interesting. I spoke with various people over the past few days, and some were saying, yeah, Docker and containers is the best thing in the world. And other people were saying, oh no, that doesn't really work for us, which is kind of interesting, just to set the stage. So, but if you want to use containers for your application, it really simplifies some things, especially, for example, for development. It's a good thing to use a container, for example, to use some other application like a database, right? So if you want to have a database running on your laptop, usually installing it directly to your operating system takes a lot of installation instructions. And once you're done with your development, you still have this database running on your machine, which you might not need anymore. And if you're using a container with a running database inside the container, it's usually just one command. The database is up and running, and you can do your development against that one. Containers are lightweight, so you can run several of them in parallel on your machine or on a server or wherever you want to run them. And the nice thing is you can just build such a container and give it to someone else, and you can just run that application, and you don't have to care that the correct operating system is used, the correct Java version is used, and all these things, because that's all embedded in the container. So these are all benefits of using containers. But how do you get your application inside that container? Now, first of all, if it's an OSGi application, it means it's a Java application. So whatever applies to getting a Java application running inside a container applies to an OSGi application. And there are different ways of doing that and then getting an OSGi application running. One famous solution is the Apache Karaf runtime, which basically is a distribution with a lot of included features. You can add your own bundles to the Karaf setup, and you have your application running. Of course, this conference is about Sling and all the friends of Sling. And in Sling, we have something similar to Karaf, which is the Apache Sling Launchpad, together with the provisioning model. So if you want to use that, you have something that is launching your OSGi framework, then installing all the bundles inside that framework, all the configurations, does all the setup, and then you have a running application. For example, if you want to use Karaf, just to give a small example here, you can write features. This is an XML-based format, and in a feature you just list all the bundles you want to have, all the configurations. You give this feature description to the Karaf runtime, and it will install all these bundles, configurations, and your application is running. And similar, we have a similar concept right now in Sling with the provisioning model. It's basically the same thing, just in a different format. So we invented our own language here to describe what makes up your application, which bundles you want to have, which configurations, and then all these things. And just to make it more complicated or more interesting, you had yesterday the talk from Dominic and Carl, where they talked about the Sling feature thing, which is basically another way or another format for describing your application, just in JSON format, but a little bit better than these two things. And I guess in the end, the idea is that both projects, Sling and Karaf, hopefully will converge to that new stuff. But obviously, we have to talk to the Karaf people to see what they think about our ideas. And that's basically all all you have to do, you describe your application, use a launcher or a runtime, and off you go with your application. Then you just have to stick all of this into the container. And of course, if you're using OSGi, there are a lot of nice things, nice features of OSGi, like the modularity, so you can just pick the bundles or the modules you need for your application. If you want to write a second application, you can pick the same bundles and add another one on top of it. So that's really a benefit of using modularity. And the other thing, we have seen that yesterday as well, briefly in the talk from Carl at the end, that OSGi has this thing of requirements and then capabilities. So you can really describe what your application or what a particular bundle needs in terms of requirements. And then there's hopefully another bundle providing those requirements. And then you can check whether the set of bundles you have really can launch and that all requirements are fulfilled, which is a very nice concept. So this is an interesting lighting test. And this basically is the application you have then running. You put it into your container. And now how do you get it really running in the end? So you use something like for example, Docker, put your OSGi application into the container, and then you start some containers with your application. For example, a Sling app or whatever. But this is only one part, because now you have your application running over there in 3 different containers. On the other hand, you have the user, and how does the user get now to one of these containers? And obviously what you need in between is some kind of load balancer, and that load balancer balances the load between these different containers. It's basically a simple setup, and we will see in some minutes how you can easily do that. And for example, if you want to have Sling running, you use the latest Sling 9 distribution, and then you have the slingshot example running in your container. You put a load balancer in front, and you can serve all the load in the world connecting to your application. And just to repeat that scenario, so you have different containers running with Sling, load balancer up front, and your application is up and running, and the client can connect to it. So the interesting part now, apart from getting your application inside the container, is how do you manage that stuff and get the containers really running. And that's David's part.
Okay, thanks, Carsten. So once you have your nice Docker image, you can run it locally on your machine using Docker, but that's kind of a development toy, really. I don't think anyone uses bare Docker in production. When you want to take your application into production, you need some sort of a management solution for Docker images. And there's a bunch of them around, like Marathon and Mesos are very popular. There's something called DCOS that works with that. An alternative would be Kubernetes, which is also extremely popular. But there's other ones as well. Docker themselves have something called Docker Swarm. And Amazon has a container service called ECS. And I believe Microsoft Azure has something there as well. So that's all nice. You can run all your Docker images there. But the interesting thing is that these provisioning or management systems have wildly different APIs to use them. So just to give you an example about how different these ones are, if you use Docker Compose, you have to put all your stuff, your images and their configuration in a YAML file, and then you run some Docker Compose commands. With Marathon, you have to basically create a JSON file that you have to post to Marathon. Kubernetes, you need to run some kube control commands to get it up and running. And Amazon ECS, you also have to do some things. You basically have to post a JSON file somewhere and then run some additional commands. So while Docker has been great in standardizing the image, the people around it have been great in creating all wildly different APIs. So it really is kind of a bit of a mess, and especially if you are a developer and you're developing a system that, an application that is contained of many Docker images that are kind of wired together somehow with a load balancer or a bunch of load balancers, it becomes very hard to switch from one to another. I mean, your product manager might say today, oh, we're going to support Kubernetes, and tomorrow they say we're going to support Marathon, and they don't really understand that that means an enormous amount of work. So it would be really nice if we can have a standard, a common API for this. And this is something that a bunch of people in Apache Arias, including ourselves, have started looking at. There is this new component in Arias, which is called Apache Arias Containers, and there's the link there. And this is basically precisely this. It's a simple API that is abstracting from the container management solutions, and that allows you to basically switch from one to another without changing your code. And currently there's only 2 implementations, so we're kind of hoping to get some more contributions. There's one that talks to Marathon, but that also works with DCOS. And there's one that works locally on your local Docker installation on your machine. So you can have the same application run an entire constellation on your local Docker machine, and then also the same application run it on Marathon, and hopefully also on Kubernetes and some of the other ones if contributions come in. So let's see what this looks like. It's really, really simple. You basically create a service configuration. So here I'm creating the configuration of the service that Carsten had a screenshot of earlier on, which is in Docker Hub called Ziegeler Apache Sling demo. So I'm basically creating a service configuration that uses that image. I'm basically telling it I need 1 CPU, I need some memory, this is the port that it's accessible on, the number of instances. You can also, it's not in the example, you can also configure a health check and stuff like that, and it's all kind of, completely standard or kind of independent of your underlying configuration. And then on the service manager, you simply call get service. And the service manager is the interesting bit, because that one is, if you're using OSGi services, you actually get it from the service registry. And it is the one that you've configured to use. So it's either Marathon or local Docker or Kubernetes, for example. And it just makes it happen. So let me do a little demo of that. I have to stop presenting. Yeah. Okay. Right. So let's see. Okay. This is very small, but I'm going to make it a little bit bigger. Okay. Is this big enough? Right. So this is just a little Felix installation that I have here. And by the way, these demos are part of the Arias demo, so you can just try them out by looking at the web page that I mentioned earlier. So this is just a very simple Felix distribution, and it has the Arias Containers API in there as bundle 3, and it also has the implementation for local Docker use. And then it basically contains the demo servlet and some standard Felix stuff like config admin, event admin, DS, stuff that you always use. And what this demo basically is, it's a little servlet that I can open up. Let me just make it. I'll make it bigger again in a minute. Oops. That didn't work. There we go. Right. So this is the demo. It's just a tiny servlet that basically gives you a UI on this API that I showed in the previous page. And here I can basically say, okay, I want to create a new container. This one is called My Apache, and it runs the Apache web service. So let me just click that. Right, so it's created, it says. Now I can go to the console, for example, here. Right, so there it is. The container started via this API, this servlet, and I can see that it's exposed port 80 on this port, because I didn't specify the client port that I wanted to use, which is always better because that allows you to run many containers that potentially use the same port, right? And then your load balancer will kind of solve the problem of the external port and always map it back to port 80 or whatever you want to use. So let's see if it worked. Going back here to this page, try to access Apache. Yes, that's what you get, right, when you run a plain old-fashioned Apache web service. Okay, so that's the local one. Now let's go back and look at, so I'm going to stop this one, this instance of Apache, of Felix. Oh, stop, 0. And now I'm going to go to another installation here, which is basically the same bundle that I wrote, but it's a whole set of different bundles that contain the configuration to talk to Marathon. So if you look at the list of bundles, there's more bundles here. There's the same API bundle. There's an Apache Arias containers for use with Marathon bundle, and this in turn uses like some specific Marathon API, which has a whole bunch of dependencies. So that's why you see a whole lot of different bundles here. But another thing that's interesting to look at here is there's configuration here. So the Marathon bundle is configured using config admin. So what I had to do is I had to add this configuration file. I'm using file install, where I have my Marathon runtime, which actually is as part of DCOS. So that's how I configure it. So let's go to that place where Marathon is running. It's over here. And you can see this is DCOS. I don't know if people have seen this before, but I think it's DCOS 1.9 or 1.10, one of the newer versions, and I have no services running there at the moment. So, make it a bit bigger. Okay, so let's reload my service. So it's back the same servlet. Again, nothing is running because now it's talking to Marathon, so it knows about nothing that is running. But now I can hit the create button again with these parameters, and you can see, if we go here into the Marathon view, we can see that it's kind of deployed the same Apache service there. So I didn't have to make any code changes. So that's already quite nice. But especially if you want to start using this, it can be interesting to look at some of the details. And one of the interesting details here is that obviously, I mean, we like to say OSGi is great because you use services everywhere. And it's all injection, and you don't have to bind yourself to particular implementations. On the other hand, sometimes it can be useful to use these APIs outside of OSGi. Maybe you have a simple mainline application, or you have to embed it in something that is not based on OSGi. And these APIs can also work outside of OSGi. And the main disadvantage that you get there is that you have to instantiate your instances yourself rather than getting injected by them. But if that's okay with you, then you can do this. And let's have a look here. Oh, that's the wrong, no. That's the wrong instance. Here we go. Right, so again, this is a demo that is part of the Arias code base. And here you can see how you can do this kind of yourself by hand. So in this case, I'm instantiating a service manager with a new local Docker service manager that talks to my local Docker installation. And then here you can see, okay, just like in the slide, I have Carsten's Sling demo. I configure it with some settings. And then basically, I'm calling get service on it, which basically instantiates it. So let's basically run that. Right, so it's running. And I'm going back here. So let's see if it's running. Right, so there it is, 9 seconds ago. And see if I can actually go to Carsten's nice picture there. Right. Sorry for all the switching, but that should appear sometime on this location. Ah, well, this typically means that it's still starting up. So I just need a couple of seconds. Basically, I was able to launch that locally. And now I can just, well, we'll leave that running. Well, let's refresh it once. It's still busy starting up. And then, but now I can basically switch back here, and instead of using the local Docker Service Manager, I can use the Marathon Service Manager directly locally. That's also possible if you're running Marathon. So I run the same thing with the Marathon Service Manager talking locally. It's running. So let's go to Marathon. Oops. Marathon is here on my machine, as you can see. It's starting it up here. Again, it takes a little while, especially because it's on my local machine. And I'm going back to the example. Oops. And let's, instead of local Marathon, use DCOS again. Again, I'm running it. So I basically just pick another implementation and go back to DCOS. And there you go. It's being launched. And just to kind of prove that it really works, oh, I hope I'm going to be right. Let's refresh this page. Okay. Well, it will work at some point. At least this is the Sling kind of saying something, but it's, I guess it's starting up somewhere. I'm not trying to, going to try to debug it, but it will probably appear at some point, or maybe did I give it? Yeah, I gave it enough memory. So anyway, so that's kind of, to show that you can use the same API to kind of deploy things in different container management solutions. So one other, let me just see, thing that is worth mentioning here. Let me go back to the presentation. Right. So this work is basically inspired by some work that was already done in the OSGi Alliance. OSGi works with RFPs and RFCs. RFPs are basically requirements documents where people say, this is what we want. And there's already an OSGi RFP that basically states the problem. We want a solution to this. And it's RFP 179. You can find it on this GitHub location. And I pasted like the requirements on the side just more as an illustration, so I don't expect you to read it. But basically, it says, we want a common API to this. And so this one is basically for creating containers or either Docker containers or other containers. It can even be used, the API can even be used to create VMs. It abstracts from that a little bit. And it can work together with another specification that is nearly finished that we're going to release probably before the end of the year, which is called cluster information specification. So cluster information is about, Carsten and I presented about that last year, I think, here as well. It's about finding out what's there. So if you are in a cloud, you can find out all the things that are there, like, what OSGi frameworks are here, what databases do I have, how do I kind of, work with these things, provision the frameworks at runtime to do something for me. And then, so that's basically when you already have an environment, whereas this new containers API is about creating those things around it in a standard way. So that's really all we had. I was just wondering if maybe we could have a discussion. Do people find this useful? Are people having the same problem with, for example, are people using Docker in the room anywhere? Yeah? Most people are using Docker. Do people find this? Do people see this problem as well? Is I guess the question. I guess people are not awake yet, but that's okay.
Or if you have any other question, of course.
Right, of course.
Well.
Ah.
So what is the exact future vision? I mean, what you've been showing is basically, when I understand correctly, one step further to what we've seen yesterday. So basically, is it more moving services into the cloud and then orchestrating with a single container, or what is the thought process behind that?
Do you want?
Okay. I guess the idea would be that everybody's moving towards microservices, right? And everybody's, by the show of hands, everybody's moving towards Docker. And I guess for this particular presentation, the focus is on, okay, OSGi is a great way to run things with Docker, so that's what Carsten showed earlier on. And then, you have a standard way of getting your Docker image. Now, you also need a standard way of getting your image out there. And currently, that, at least in our opinion, that is lacking.
And with this API, you can write some kind of management application, right, which then starts the containers on demand or whatever, and then sets up a microservice-based system, things like that. Yeah. But it's up to you on what you do with the API.
Thank you.
I mean, in general, I think it's always good to define small kind of technologies, like small things that do one thing, and then it's up to the users to make big, fantastic kind of pieces of art out of that. But yeah. Matt.
I promised you a question. In your service manager config, you showed it asking for certain resources, which is what I kind of expect from any cluster manager using these containers. So my question is around when you're asking for those resources, obviously if I'm doing that on my local machine, the number of resources I can ask for is limited to, it's a lot more limited than it would be if I had a big cluster. So what's the technique that you should be using for varying what my configuration would be when I test it locally versus when I'm actually deploying it into my cluster? Or is it just kind of however you want to do that at the moment?
I think that's actually a very good question. I think there should be the technique should be that you keep them the same. So your container should be, if you really develop your container well, it should be fairly small. So you can run it on your local machine, but you use the same relatively small configuration when you're really deploying it in the cloud. And then the best way to deploy it is if you need to scale up, you just deploy many of the smallish containers side by side. But it gives you much more flexibility in kind of spreading those out over the resources that you have. If you have a lot of small containers versus like a small number of very large containers. Large containers generally don't fit so well with Docker-based, deployments. So I would just keep them small. I don't know if you agree.
Yeah, makes sense to me.
Thank you. Petra?
Bertrand?
Don't you think the name service can be a bit confusing, considering that we have also OSGi services?
Right. Okay. Yeah. So I guess we can have a nice hour-long conversation about names. But I guess the reason why it's called service is that if you look at all these technologies like Marathon and Kubernetes, and these things call this a service, like a microservice. But yeah, I mean, in this case, the service manager is also an OSGi service, so that may be a little bit more confusing. But yeah, if you have a better name, then yeah.
Yeah, maybe deployment service or something.
Right.
It's not a good time to discuss names.
But point taken.
Thank you. Any other questions?